We have discussed in the previous lecture about the how Aryabhatta named the two trigonometric ratio, which was sine theta and cos theta. In this lecture, we will study about the how trigonometry evolved further. Now we have already shown that if the angle of consideration if our angle of consideration is theta, then this side AB is taken as perpendicular, or this side BC is taken as base, and AC is always hypotenuse. We have already learned about it. Okay, so if we consider this angle, the Aryabhatta named two ratios, which was Giasso, or which modified in when time passes as sine theta. Now we call it sine theta. Similarly, Coti-Giasso, now we call it cos theta. So why Aryabhatta never go for naming of another four trigonometric ratios? Answer is simple, that if you solve the problem in trigonometry involving triangle, then you can see that if you tackle only sine theta and cos theta while solving the problem, then it is easier. There is no need for another trigonometric ratios in most of the cases. So perhaps Aryabhatta never bothered about the naming of other ratios. But sometimes we will encounter the problem in which sine theta and cos theta will be handled. If we take sine theta and cos theta, the problem will become very lengthy. So sometimes sine theta and cos theta is not easy to handle for the particular problem. When this idea goes to Arab by some scholar, and then goes to Greece around 680 to 1800, because the date of Aryabhatta is perhaps 500 AD, in which he wrote Aryabhatiam about the trigonometry. In this book, they gave the detail about the algebra and trigonometry. So perhaps it must be that the scholar from Arab traveled to India around 1600 AD, and then the Greece scholar also tackled this problem, this type of mathematics, around 600 to 1800 AD. After tackling this new kind of trigonometry, because it is easier to handle the difficult problem by trigonometry, so they discovered many things and named the four ratios after Aryabhatta. So how they name the other four ratios, trigonometric ratios? Here in a triangle ABC, you can see here ABC. If you take theta as our consideration for perspective, then this AB must be your perpendicular line, and then BC must be your baseline. So if you take AB by BC, means if you take this ratio of length of this side upon this side, but if you add the perspective, means if you add the information about direction, or from where or along which line you observe something, then it becomes P by B. I have already told about you in the previous lecture. So they name it as tangent theta. That become now tan theta. Similarly, BC by AB, by adding perspectives, it become cot cotangent theta becomes cot theta, and similarly AC by AB adding perspective becomes cosecant theta or cosec theta. And the last is AC by BC, which becomes, as time passes, secant theta or sec theta. So we have 6 trigonometry ratio, and here if we divide P to B, then we got tan theta, you can see here, and if we divide P to H, we got sin theta. If we divide B to H, we got cos theta, and similarly if we divide B to P, we got cot theta. In the similar fashion, if we divide hypotenuse to perpendicular, we got cosec theta, and the hypotenuse to base, we got sec theta. So here there are 6 kind of different ratio in a right angle triangle, which is sin theta, cos theta, tan theta, cosec theta, sec theta, and cot theta. Now I am giving you some further detail about the trigonometry. So if you observe the ratio, you got 3 ratios are reciprocal to the other 3 ratios. Have you observed? So here we can say P by H is the reciprocal of H by P, because P is here in numerator, here in denominator, and similarly here H is in denominator and here H is in numerator. That's why this is reciprocal to this, or this is reciprocal to this. So we can say P by H is sin theta and H by P is cosec theta. We can say sin theta is reciprocal to cosec theta. Yes or not? Are you getting my point? So we can say that sin theta is equal to 1 by cosec theta, because sin theta and cos theta are reciprocal to each other. In a similar way, we can say cosec theta is equal to 1 by sin theta. Yes or not? Similarly, cos theta and sec theta are reciprocal to each other, and in a similar fashion we write this kind of relationship. And tan theta and cot theta are also the reciprocal to each other, so this kind of relationship also can be evaluated. So for you, these kind of things is easier. It is not very difficult to grasp. Okay. Now further, this relationship can also be written as sin theta into cosec theta is equal to 1. Are you getting my point? Because this sin theta and cosec theta are reciprocal, so if you multiply it with the reciprocal, it gives 1. For example, if 2 is multiplied by its reciprocal, means 1 by 2, then the 2 into 1 by 2 gives 1. Or x is multiplied by its reciprocal 1 by x, then it gives 1. So here cosec theta is multiplied by sec theta, gives 1, and tan theta is also multiplied by cot theta, it's gives 1. This is also these are easier for you, and this is very important relationship in trigonometry. Okay. Now, after going further detailing for trigonometry, I mentioned some important theorem which is used here and there and many times in mathematics. So here first theorem is Sulva Sutra. Actually, this is given by Bodhayan, Apastamba Sanghita. He wrote around 600 BC, and in this book there is a formula, or there is a statement which is called Sulva Sutra. Sulva means leaves or branch. So Indians elegantly name these kind of things, even mathematics, Sulva Sutra. So in this statement, he mentioned that if you draw a Yajna Vedi, do you know where you done your havan in or for some sacrifices in temple. So if you create a Yajna in the fashion of right angle triangle, and the people are here, and people are here sitting, he must have to sit in a square space. Here you can see, you can create a square by AC side. This is the square area, and this is also the square, this is also a square. So three people can sit here to give some sacrifices or prayer in the Havana. So they perform these kind of experiment in ancient time in India. They say that if you take the area of largest square, which one is the largest square? Obviously this one, because if AC is the one of the side of this square, it means this is also AC, this is also AC, because every side of a square is same. And you already know that the AC is the biggest side, or hypotenuse is the biggest side in a right angle triangle. Are you getting my point? That's why the area of this space, this region is highest. Now there are another two regions here. One is here and one is here. Surprisingly, if you add these two, the area of these two regions, you must got the area of this region. It is very interesting. So this is the all about the Sulva Sutra. So we can say here h square must be equal to p square, because here side of a square is p, one side of a square is p, so every side of a square is p. So the area of a square must be side square, that's why it is p square, and similarly it is b square. So a statement said that the area of largest region must be equal to the smaller one. That's why h square equal to p square plus b square. Actually, Bodhayan never give the proof of this statement. He only calculated as they experiment on it or practical on it to making a Yagya Kunda or Havana Kunda. That's why they never gave or wrote the proof of Sulva Sutra. But perhaps, now you can learn the proof of it in your chapter Quadrilateral, class 9. Okay. So this was the practical phenomena for Bodhayan, and they measured the length of it. They measured the length of it, and a Yagya, they created a Yagya Kunda, and they know about this area must be equal to this plus this. So it is given by practical observation, not the concrete or mathematical observation. But now we know that how can we prove this kind of statement. You can know in class 9 in quadrilateral chapter. But after about 400 years after the Bodhayan, one philosopher of Greece came who know mathematics, who know astronomy, who know inner science or spirituality, and several kind of sciences which were available in those times. So he was a philosopher.